I'm Annalise Hoffner.
I'm Emily Osterman.
And I'm Eva Pontius.
Our first year engineering design day project was the fabric bucket, and we chose Carry the Solution as our team name.
A major issue in the developing world is the lack of access to clean water. Often, people must walk miles to a water source which may or may not contain safe drinking water and carry the water back to their homes. One way to alleviate the burden of these journeys is to create a more effective vessel for carrying water. The objective of this project was to create a portable, compressible bucket made of fabric. Our fabric bucket had to be portable and able to hang from a hook for testing and hold 1 gallon of water for 1 minute without leaking. When empty, it had to fit inside a 6-inch by 6-inch by 6-inch cubic container. In addition, the bucket had to have at least 50% of a fibrous material in the water containment area of the bucket and could not include pre-laminated fabrics.
On our research, we determined that a durable, lightweight fabric would be best. We initially got nylon, ripstop nylon, and polyester to test. We also determined that a hydrocarbon durable water repellent coating would be best for our bucket. In comparison to other coatings, hydrocarbons have a much lower risk of contaminating the water in the bucket. During our initial brainstorming, we thought of a structured rectangular prism or cylinder shape for our bucket. We thought we would make the strap out of a braided fabric to provide more support. We also considered having a lid or screw-on cap to prevent contamination of the water inside the bucket. Our ideas changed after we obtained our materials and conducted initial tests.
After constructing different models, we decided that our bucket should be created with a cylindrical shape that would require only 2 seams rather than 3. We initially tested a polyurethane coating on each of the 3 fabrics, but determined it would not be enough to waterproof the fabric. Next, we tried a beeswax and linseed oil mixture on each of the fabrics. The polyester reacted more favorably, and the coating was much less likely to crack than on the nylon fabrics. We also decided that a drawstring strap would be the best design because it would require the least amount of penetration and manipulation of the fabric bucket. This would also make the bucket less likely to become structurally impaired and leak water.
The full-size prototype we created fit each of the constraints, except for being able to hold water without leaking. We constructed it from polyester fabric and attached the paracord drawstring strap to the bucket prior to coating. We then applied the beeswax linseed oil coating to the bucket, using a hairdryer to melt the coating into the fabric. After the first coating, we filled the lower portion of the bucket with water, and it leaked from the bottom seams, especially where the power cord connected to the bottom. Based on this, we decided to coat the seams again.
A large part of the scoring process involved different multipliers. Our design could be worn as a backpack, contained a laminated fabric that we constructed, and was composed of non-toxic materials. Additionally, our fabric bucket had the lowest mass of all the groups in our session at 74 grams, which we were told was extremely impressive.
Unfortunately, while our bucket was able to hold a gallon of water, it began leaking after 20 seconds and could not be judged in competition. Surprisingly, the leaks were not at the seams but from the pores in the fabric on the sides of the bucket. We had added another coating of the beeswax linseed oil to all of the seams 2 days before competition, but not to the entire bucket. Had we applied this coating to the entire bucket, it would have held water longer, possibly even for the entire minute. While we would not have come in first place even if our bucket had held the water without leaking, we likely would have placed in the top half of the teams due to the low mass of our bucket and the multipliers.
If we had to do this project over again, we would expand upon our design. We would test various application methods for applying the beeswax linseed oil coating to the fabric and would apply a more even and thicker coating to the polyester.
In addition, we would also choose to add a second layer of coated fabric to the bucket design. While this would add weight, it would create a more durable bucket capable of holding and transporting water.
The beeswax linseed oil coating began cracking and peeling off after it was applied. This could have been in part to the application process. but it could also be attributed to the ratio of beeswax and linseed oil we used to make the coating. With further testing, we could determine a better ratio of beeswax to linseed oil to prevent the coating from cracking and increase the ease of application.
After making these improvements, we could focus on increasing the scale of our design and producing a bucket capable of holding a greater amount of water.
Melt beeswax over low heat. Do not add beeswax pellets to a hot pot.
Seek out advice from faculty and upperclassmen as soon as you can. This will give you more time to brainstorm, develop a prototype, carry out testing, and make any necessary improvements. Overall, our FED project was a great learning experience. We developed new skills and knowledge about teamwork, the engineering design cycle, textile engineering, and improving our designs.
What are you doing?